Hey everybody, this is Larry. This is December 25th so happy holidays, Christmas, whatever you like to celebrate. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem, diagonal traverse. I do solve these live, so it may be a little bit slow on the solution, but I go for my thought process, so let me know what you think. Okay, so basically you're given a matrix, which is m by n, which is a little bit messy. We're trying to get it in some order, which is okay. So the key thing to note, which is something that you get practice with, or like you've done similar problems, you may notice. Maybe it's something that you can also notice from practice in general, or just like working on this problem. But that's how I'm able to figure this part out. Is just that it's just that there is a property which I'll mention, obviously, that I get from practice, which is that the diagonal, you could kind of reorder the diagonal, and you can renumber them in a specific way. And the way that I would renumber it is, and there are a couple of ways that you can do it for this problem. I think you can definitely go, just diagonal, diagonal. You could do for loops. You can put things in a queue and a hash table and stuff like that. But the thing that I would think about is just numbering these diagonals. And for example, this is diagonal 1, and 2 and 4 will form the diagonal 2 and so forth. And the way that I would think about it is just, if you want to call this xy for rows and columns, then x plus y would define the column number, and then the what I want to say is the mod, the parity of that number will determine which direction you go. And from that, it becomes very straightforward in terms of understanding. Once you're able to understand that, the easy way to do it, there are harder ways to do it as well, but that's what I would think about. Yeah. Okay, so there are definitely very error-prone ways, and for interviews, you may think about different ways as well. For me, I think what I'm going to do is try to implement it like I would do it in a competitive nature, which means I'm going to optimize for solving speed, right? And everything is going to be, ideally, linear time and linear space, just to kind of be, and you cannot do better than linear time or linear space, because you have to read the input, so that's going to be linear time, and also our output, which is also linear time, and the output space is also going to be linear. So you can definitely use multiple of that, and that's basically what I'm going to do. There are definitely a lot of different ways to solve this, as I mentioned. I'm going to just do it a funky way just for fun, and it's Christmas, so maybe it's festive. I should have worn a Santa hat. I have a Santa hat that I haven't worn that much this year because, I haven't gone outside that much this year. But yeah, maybe next year. Okay, and it's very hot in my apartment. So okay, so now let's set up for, I guess, n and m. But I like to ignore m and n because it's confusing. Sometimes I use r and c for rows and columns. Sometimes I use just the word row and the word column, or cars, which is similar, I suppose. Just double checking if there's any constraints, because in some cases, if rows is equal to 0, then just return an emptiness, I suppose. Don't know if that's the right answer to return, to be honest, but it's sometimes not defined anyway. So yeah, so then now the way that I would do about it is just very hacky, which is d is equal to d is terrible, but basically diagonals is equal to, I'm going to use a default dictionary in Python, and what that does is just gives you a dictionary that if it doesn't exist, it'll create whatever is in the function afterwards inside, and in this case I want a deck inside, so then that'll be easier for me to. Do I need a deck? Yeah, I mean, I could either do a deck or an array, so maybe this is actually a little bit. So yeah, let's actually do list. Yeah, actually, let's use deck. So, because you can, with a list is the same idea. In this case, you just reverse the thing afterwards. But let's use a deck so that it is, so we don't have to do any reversing. So okay. So then now we just do something like for x is in range sub rows, for y in range sub columns, and we could do diagonals of. Okay, so actually, let's just say diagonal is equal to x plus y, and then we could do maybe if someone like if diagonal mod 2 is 0 0. So if it's even, we want to go from large number to small number. If it's so, and if we're going from row by row, then we actually want to, for even rows or even diagonals, we want to increase the number in the front, and otherwise we will return in the back. And the way that I'm explaining it isn't just like some reading off the thing. I'm actually looking at this thing, this diagram, and then I go, okay, for a given diagonal, well, an odd diagonal, I look at every row and then what changes. Well, in this case, in an odd diagonal, when you get a new, like on a row that's underneath, when you add a new number, you want to add it to the back, and then so forth to the other direction, right? So okay, so what did I say even was? So for even diagonals, we want to insert it to the front. Append left, I think. Matrix of xy, else diagonals. And of course, you can actually do this in the list, and as I say, you could just invert the diagonal afterwards on either odd or even diagonals. But either way, it's going to be the same as you look at each cell constant number of times. So okay, so then now we just have to group them back together, and for that, and also note that in this case, actually, I use a default dictionary because I was a little bit lazy, but actually we can actually do a list where the number of diagonals is just m plus n, or rows plus columns. So actually, let me do it that way because it feels like the right thing to do. So we want one for each diagonal, so it's rows plus columns. So yeah, so this is slightly better, I think. And what this also led us to do is that now we can just concat them all together. Is there a join? No, join doesn't do that, right? I think I'm just thinking if you're in a functional language, you can do something really quickly. But basically, the idea is just have an answer for diagonal array in diagonals, answer dot, I think extend, or just do it this way, to append, and then just return answer. Let's run it real quick. Yeah, so this looks good. Let's submit it. And of course, as I mentioned, there are a lot of linear algorithm. You can actually just, based on this mapping, you could, for an x of y, you can do some mapping with respect to the position that it would be in. It's just a lot more. So then in that case, there'll be one extra space extra on top of the output. But as I said, I'm trying to like speed run this a little bit. It is the holidays. So, and I try to think about it in a way where like, where I make the fewest off by one errors as possible, or not even fewest off by ones, but fewest potential for off by ones. And here it looks pretty straightforward in terms of off by one. The only place that I may have an off by one is if I do this backwards in terms of risk. So that makes it easier to debug, because I'm wrong, then I just flip the signs or something like that, right? Yeah, that's all I have for this problem. Like I said, it's going to be linear time, linear space, no matter what. And in this case, linear is in the size of the input, which is the number of elements, which is rows times columns. Yeah, and it's linear times in terms of time and space. That's all I have for this problem. Again, Merry Christmas. Hope everyone has a great time. As I always say, stay good, stay healthy, and I will see y'all soon. Bye-bye.